All right, the last thing in this section is the difference quotient. And the difference quotient, this might look familiar to you. This is an average rate of change, and it's the average rate of change of f of x from x to x plus h. All right, so all we're doing is plugging x and x plus h into the difference quotient. Okay, so it's a composition sort of functions because we're plugging the x plus h in for x and then evaluating. Okay, so I think we did this. We did this probably in chapter 1 and chapter 2 a little bit. So, but this difference quotient is very important for calculus because this is the basis of the derivative. So now we want to find the difference quotient for this function f of x equals x squared plus x. All right. Now it gets a little messy because there's a lot of algebra involved. So I like to break it down. I like to break it down and just look at f of x plus h first. And then simplify that as much as I can and then do the rest of it. I also sometimes like to do this, is do 1 over h times f of x plus h minus f of x, just because that denominator just gets a little messy. So, because dividing by h is the same as multiplying by 1 over h. But let's take it one step at a time. Let's find f of x plus h. So I'm just going to replace x with x plus h, right? So I get x plus h, that's quantity squared, right? And then here I have to replace this other x with x plus h. Okay, so I've replaced x with x plus h. And now let's expand that out. All right, I'm going to expand this square. And when I do that, I get x squared plus 2hx plus h squared. And then I really don't need these parentheses here. So I'm just going to write plus x plus h. All right, so we've expanded out the f of x plus h. And now let's go ahead and put it into the difference quotient. Delta y over delta x. All right, just a rise over run calculation. So the f of x plus h is just x squared minus 2hx, plus 2hx plus h squared plus x plus h. All right, that's that whole thing. And from that, we're going to subtract f of x, right? The whole thing. So I'm going to put parentheses around it, x squared plus x. All right, and then the whole thing is over h. And I'll just go ahead and put it in the denominator. So, or I could move it and make it a multiply by 1 over h if I wanted to. But I'm just going to leave it like that. All right, let's simplify. Now, I can distribute this negative, right? I'm subtracting the whole thing. And when I do that, I'm going to get an x squared minus x squared. And so those x squareds will cancel. Here I have an x, and then this will end up being minus x. And so those will cancel too. So let's see what we have left. We have 2hx plus h squared plus h all over h. And you can see that every term in that numerator has a factor of h. So I'm going to factor it out. So it becomes 2x plus h. Oops, I think I copied something wrong. Oh no, that's right. No, I didn't. Never mind. All right. All right. So I'm factoring out of h. So this will be a plus 1, right? When I factor out when I have this plus h and I factor an h out of it, I'm left with 1. And this is all over h. And so those will cancel. So my final answer is just 2x plus h plus 1. All right. That's the final answer for my difference quotient. So it simplifies down nicely. And that's it. That's as far as we're going to go right now. But essentially what we're eventually going to want to do is then, look at this is a rate of change calculation. And we want to look at what happens when that h value, which is basically the difference between, the two, it's the interval width of the rate of change calculation. As that goes to 0, what happens? We're looking for the instantaneous rate of change, right? So we want to let h go to 0. And then what we end up with this is the derivative. So if we wanted to look ahead, well, if h goes to 0, then you're left with 2x plus 1. And that is the derivative of x squared plus x. All right, but that's getting a little bit ahead of ourselves. But that's all I have for this section, and I'll meet you in class.